So today we're going to look at surface area. If I can do this without touching my screen. We're going to look at surface area. That's terrible. It's really hard to write without way up high without my hand touching. Here we go. Surface area and volume of spheres. And so these are notes for 11-10. And then we need to look at the parts of a sphere. Anybody know what this is called?
Diameter.
It is. So it's similar to a circle in that respect, right? What is just, oops, gotta get rid of that. What is just this point here? Just the point.
Origin.
Close.
Center.
Is only Dustin going to participate in this morning's little lesson? It is the center.
Oh, I said that.
I know.
Oh,
That's why I said, are you the only one who's going to participate in this guessing game? All right, everybody, what's this?
Radio.
There. Oh, that was so much better.
Yeah, I still
And then I'm curious to see if anybody knows what this is.
circumsphere.
It sounds like perimeter. It's not circumsphere. It looks like circumference. It's actually called, anybody remember Charlie Brown?
Yeah. All I really remember is
Remember the Great Pumpkin? Right, the Great Pumpkin? Well, you're like, that's the Great Pumpkin? No. This is the Great, yes, this is the Great Circle. Which is, if I sliced a sphere directly in the middle, directly on a diameter slices a sphere exactly in half. Then if I open that up, I would have a nice perfect circle, and that great circle, as Zach said over here, would be the circumference, right, of that circle. All right, so let's look at some problems. We're just going to do a few of these. So if I were you, the only formulas that I would learn would be these. Do not learn the hemisphere one, because I'll show you how to derive the hemisphere one just by knowing surface area and volume of a sphere. So think of it this way. Volume, what does this part of the formula right here look like?
pi r
Yeah, pi r cubed, but what does it look like?
the radius, the area.
It kind of looks like the area of a circle, right? But notice that pi r squared right here, the actual area of a circle, is down here in surface area. So if you think of it in this way, because you have to memorize that formula, if I'm doing surface area of a sphere, pi r squared, the area of a circle, is within that, and we've got 4. We're going to multiply it by 4. Why does that work? Well, somebody smarter than you or I went and derived this for us, and we're not going to worry about their derivation. But remember to yourself that surface area is area. Area of a circle is pi r squared. You just have to know that it's 4 times pi r squared. Okay? So then when you go and do volume, isn't volume cubed? Aren't units of measure in volume cubed?
Yeah.
So we've got pi r cubed here. That gets us our cubic units of measure. Whereas you have pi r squared here, that gets us our squared units of measure. The only difference is between these, aside from the fact that I've got an extra r here, they both have a 4, right? Remember volume of pointy things was 1/3? Well, I know that this is not at all pointy, but we had 2 volume formulas before. One volume formula was big BH, the other volume formula was 1/3 big BH. So you can kind of view this as taking the surface area formula and just taking 1/3 of it. What's 1/3 of 4? 4/3. And then we have to tack on another r, so we have r cubed, so that we get those cubic units of measure. So there are some ways for you to memorize that formula, but you got to memorize it. The issues on your last quiz, what do you think? You didn't know your formulas. If you didn't know your formulas, you flat out failed that quiz. I graded them last night for your class. You either did really well, or you did really badly. And it's all a matter of knowing those formulas. So I warned you that it was going to be a hard quiz if you didn't know your formulas. If I gave you the formulas, I'm sure that 80% of you at a minimum would have done fine. But it's a matter of, I don't have control over the fact that Arizona Merits doesn't give you the formulas. Now, will that change this year? I don't know. You'll have to tell me. Maybe we'll jump up for joy and find out that there are actually formulas on that test. But last year there was none. Not a single one. So you've got to memorize those formulas. You just have to buckle down and do it. Okay, so let's just do volume and surface area. Well, we'll do just the volume of the sphere on number 2. So if I'm going to do volume, I'm going to do my formula first. So 4/3 pi r cubed. I love spheres because there's only one unknown in these formulas. What is it? R. So I'm going to find r on this particular sphere. What is this dimension that they gave you?
16.
What is it?
16.5.
But what is this dimension? That's the diameter, right? So then the radius would be that cut in half. What's 33 divided by 2? 16.5. And then if you know your formula, you can just run right through with it. Here's how I would write it. I would write 4 pi times the 16.5 centimeters cubed, and all of that divided by 3. Why am I writing it that way? Yeah, we're just going to do all of this in our calculator first and then hit enter equals and then finally divide by 3. So in your calculator you should be, right? You should be cubing that 16.5. So you need to find a button on your calculator. If you've got the graphing calculators, so the graphing calculators, you're going to use the caret button, which looks like this. It's on the far right-hand side above the division button. So you're going to use that caret to raise a base to an exponent. If you have the scientific calculators, so scientific, you're either looking for the y to the x button or the x to the y button. And for both of these, you have to put the base in first, hit that button, whether it's the caret button or whether it's the y to the x or the x to the y button, and then put in your exponent. So when I'm raising this to the third power, I'm going to put 16.5 caret or y to the x, then 3, and hit equals or enter. And on some of your calculators, when you hit the exponent, it automatically gives you the value. And so we get for this cubed, you should have a value of 4,492.125. How many got that? 4,492.125. So if you got that, then you figured out how to use your exponent key correctly. All right, then you're going to multiply that by 4. And we could do an exact volume, which I guess I will here, divide by 3. I haven't multiplied by pi yet. Your exact volume is 5,989.5 pi. My centimeters is cubed. And then if you want to multiply that by pi, you can get your approximation. So your approximation is 18,816 points. If you round properly, it's going to be 57 centimeters cubed.
Yeah, now that you just put it the way we did it, we have multiplying by 4 at the top and then dividing by 2.
Absolutely. Right? Yep. And that's what I would do. Question.
This when I saw the 4/3.
You understand what? All right, so Tristan, let's start again. Clear out your calculator. Hit the clear button. You're going to put in 16.5. Hit your y to the x button. Then put in 3. What does your screen say? Does it say a 3 or does it say a big number, 44? What did? Okay, so that's 16.5 cubed. Then you're going to hit times 4 equals, then divided by 3 equals. Did you get 5,989.5? Okay, then times pi, and you should get this answer. Are we good now? Right. Well, you already multiplied by 4, so you don't want to multiply again. Can I what? Right, but I wanted to get an exact answer, so I held pi out. Just depends on what's being asked. Okay, so then let's look at the surface area. And again, I'm choosing number 4 because it's harder. They don't give you the straight radius. But this time, look at how they did the diameter. Does that matter? You don't have to have the diameter coming through the great circle. Anything going through the center of that sphere is going to be a diameter. So here they've given you a diameter. What's the radius? 12 millimeters. So this time we're going to use the surface area formula. And again, the more times you write it, the more likely you are to learn it. And the problem is you're not writing it in your homework. I see a lot of you skipping the formula part, and that's half the reason why you don't know your formulas. So this one, we're going to plug and chug. 4 pi times, some of you are not squaring your problems correctly. You're squaring the pi within the radius, and we don't want that. So if you square the 12, you get 144 times 4, your exact surface area is equal to 576 pi millimeters squared. Then if we want to multiply by pi, you're going to get an estimated answer of 1,809.56, if you round correctly, millimeters squared. Are you on fire? It's Friday and you're on fire.
I'm always on fire. Just whether actually to show the answer to fire.
I would get in the habit of doing both, because on Arizona Merits they could ask for an exact answer or an approximation. So get in that habit of doing both, and then you should be okay. Yes. You got it? Perfect. So is it working now?
Yeah.
Oh, is there a K button there? Okay. Okay. Good. All right. So let's talk about a hemisphere. Shh. If I were you, gotta listen, I would not memorize those.
You don't have to tell me twice.
I just wouldn't. So what I would do with a hemisphere, let's think about this. For volume, we're just going to find the volume of the sphere and do what?
Divide by 2.
Divide by 2. That's what I would do. That's what I would do. So let's find the volume of the sphere. So volume is equal to 4/3 pi r cubed, right?
Wait, are we going to need the surface area too?
We'll do the surface area also.
Like, of the hemisphere? Because I kind of crossed it out already. So
Yeah, we're going to do the surface area on the other side. So on your back sheet.
No, I know. I'm saying, like, are we going to do the hemisphere surface area?
No, no, because I'm going to show you how to find that one too.
Okay.
Now, if you want to memorize the formulas, go right ahead. Like the surface area one isn't so bad. However, because you're essentially taking out a pi r squared, right?
Yeah.
So if you're taking out a pi r squared from 4 pi r squared, 4 pi r squared minus a pi r squared is 3 pi r squared. So you can derive it yourself. But
Yeah.
we'll talk about it.
Okay.
Okay. So, we technically need to add it in, but neither here nor there. We'll derive it. So let's go ahead and plug in. They have actually given us on this one radius, haven't they? So again, I'm going to adjust my formula. So I have 4 pi times my radius is 5 kilometers, and I'm going to cube that. I'm going to take the whole thing and divide it by 3. So I'm going to hold out the pi. I'm not going to multiply the pi through. So I'm going to take 5 to the 3rd power. Using your button, what did you get? 5 to the 3rd. 125. And then times 4, you get 500. So the exact answer is 500 pi divided by 3 kilometers cubed. You can write it just like that. That's fine. It's a great big old fraction.
That would be considered the exact answer?
Yep.
So we wouldn't divide by 3
Nope.
first?
Because is 500 divisible by 3?
No.
Nope. So it's a fully reduced formula, which is fine. Because if you divide by 3, you're going to get a decimal that's 0.3333 or 0.66666 repeating, right? Yeah. And that's fine. So at this point, to get our estimated answer, you do want to divide by 3. So if you divide by 3, you get 166.6666666, right? You still have to multiply by pi, so times pi, and I get an approximate answer of 523.60 kilometers cubed. And that was multiplying by pi and dividing by 3. Any questions? Oh, we're not done. Why are we not done? Yeah, we forgot.
Oh, divided by 2.
Yeah, so see what happens. We should have just done that at the beginning. So let me throw this in here. Divided by 2, right? So I've got this over 3. We estimated it to be 523.60.
Does that mean we shouldn't have rounded that?
No, well, we're rounding on paper, but not on our calculator. Okay? So then we're going to do our final divided by 2 to get our volume. And our final volume is going to approximately be equal to 261.80 kilometers cubed. Because it's a hemisphere. It's half of a sphere, isn't it?
Wait, so then is the 500 pi over 3 still
The 500 pi over 3 is the exact volume for a whole sphere. We haven't divided it by 2.
Hemisphere, would we have to divide that by 2 as well for the exact answer?
Yes, if you wanted exact answer, you would have, there'd be 6 underneath here. Or you divide this by 2, wouldn't you have 250? Don't worry too much about that.
Okay, I was just wondering.
Yeah. And so then we took this estimated answer, which in our calculator was the full decimal, and divided that by 2 to get our final volume. So the only extra step you have for volume of a sphere is just divide by 2. But you got to remember to do it, right?
Yeah.
I almost oopsed. Okay, so let's go to the second page. And then we're going to find the surface area of the hemisphere. So let's do 8. So surface area of a sphere is 4 pi r squared, isn't it?
Yeah.
Here's the deal. Let's think about this. If I find the surface area of the whole sphere, I'm finding just the area of this plus the area of this, right? I would need to divide this by 2 because I only want half of it, right? But then, don't I have to add in, now this is open to the air, whereas this great circle was not open to the air before, was it? So I have to add back in what? 1 area of a circle, pi r squared. So you can derive that formula if you don't want to memorize it. Honestly, it's easy to memorize it.
Wait, can you explain why we do the pi r squared thing?
Yes. So this is your surface area of a sphere, right?
Yeah.
If I do surface area of a sphere, it's this side plus a whole nother hemisphere, right? This right here is this hemisphere plus a whole nother hemisphere that we don't have, right? So then I want to cut it in half because I only want half of it. As soon as I cut this sphere in half, isn't this now open to the air?
Oh, it's flat.
So I have to add in that flat circle that is now touching the air. Does that make sense?
I completely.
Now let's talk ourselves through it. What's 4 divided by 2? 2 pi r squared plus 1 pi r squared is what? So you can derive the formula for surface area of a hemisphere by thinking yourself through it. Now, a lot of you are just going to want to memorize that. But that's up to you how you want to deal with it. I've taught you how to derive it, right?
Isn't that what this says right here?
You could just memorize 3 pi r squared.
For like every type of like
Every hemisphere. But that's how it was derived in the first place. That's why it's 3 pi r squared. Does that make sense? Okay, so you either derive it or memorize it. It's your choice. Okay, so here we go. All I need is radius. What have they given us?
Everything.
No, what's this?
Diameter.
That's the diameter. So what's the radius?
6.1.
6.1 centimeters. So it equals 3 pi times 6.1. That's a 6.1. Oh, cancel. That's what happens when I touch funny buttons. All right, so 6.1 centimeters, and then we are going to square it. So 6.1 squared is, did you get 37.21?
Yeah.
Times 3. Our exact surface area, our exact with pi in it, is 111.63 pi centimeters squared.
When the square ends up, you can just use my sheets as the answer.
Perfect. I'm sure I could. Then you're going to multiply by pi to get the approximate answer, and you get 350.70 centimeters squared. Are we okay with how to find the surface area of a hemisphere?
Oh, yeah.
I'm going to have you do some of these on your own here in a minute, but let's just look at some of the application problems. We ready? Because that's really where the harder problems come into play. So number 9 says the volume of a sphere with a great circle area of 201.06 square inches. So we're finding the volume. Well, what they have given us here is the great circle area. If you're looking on a sphere, what they have given us is this area of that circle as if we had sliced through it. So it's not the circumference of the great circle, it's the area of that great circle. What can I do with the area? What do I need for volume of the sphere? What's the only unknown?
R.
Radius. Can I find radius given area of a circle?
Possibly.
Yeah. So area of a circle is pi r squared, isn't it? So this is step 1. So they have given me the actual area, which is 201.06, and I'm going to leave my units of measure out. And that's going to be equal to pi r squared. So I want to solve for r. So won't I divide by pi to both sides?
I was just going to say that.
You're so smart. And so then I get r squared, and then I'm going to round on paper, but not my calculator. So in my calculator, I'm going to take 201.06 and divide it by pi. And we get 63 point, we get a long decimal, 9993, yeah. And I'm just going to round there. But my calculator says a lot more, right? So to find r, won't I take the square root of both sides?
Wait, what did you say? How was that? Just like a bunch of nines?
Yeah, 99939.
999.
Yeah. So it's really 64. And you're going to see when we take the square root, it's going to be 8. So when you take the square root of that second, or whatever, however you do it on your square root, find the square root, I get 7.9999999. Isn't that 8? Okay, so I'm going to say that my radius is equal, it's really an approximation, equal to 8, and then we're in inches. So now I have a radius. I want the volume of the sphere. So step 2, what's your area formula for volume of a sphere?
For area for volume of the sphere, you mean
What's the volume of a sphere formula?
the 4/3
Pi r cubed, because volume is cubed, right? And so now we just run it through. 4 pi times our radius, which is 8 inches. We're going to cube that. And we're going to divide the whole thing by 3. So my exact volume, so 8 cubed is 512 times 4 is 2048 divided by 3. It doesn't go in there. So we've got 2048 pi divided by 3 inches cubed. That's our exact volume. So take that 2048 divided by 3, you get 682.6666666. You want to multiply it by pi. I'm not going to divide by 2 this time. Why? I have a whole sphere, not a hemisphere, right? So then we get approximately 2,144.66 and it's inches cubed. You were thinking what? Oh, the picture above, yeah. All right, so we all okay with that. So sometimes we use the great circle to find radius. Sometimes they'll give you the circumference of the great circle, and you plug that in to a circumference formula, and then you solve for r. So number 10 says find the surface area of the figure to the left. So we're going to use some prior knowledge. So we've got this. What part of the surface is not showing on this one? The big B. And then we've got our hemisphere, but this time you wouldn't want to use the hemisphere surface area formula because the great circle is not showing. So you would want to do half of the 4 pi r squared, right? So we can actually create our own formula. So the surface area of this, what is the surface area formula for a cone? Pi RL plus big B, right? Do we need big B?
Yeah.
Nope, we don't need big B, so we're just going to add to that the surface area of a hemisphere, or I'm sorry, the surface area of a whole sphere is 4 pi r squared. What's half of that? So we're just going to add 2 pi r squared. That's our formula. So we derived our own formula. I need to know r and L. So look at the picture. Do I have radius? What did they give me? Diameter. So what is the radius? 4.5. Nathan, there should be one at your desk for that. Just saying. What's my slant height?
13.
Isn't that slanted?
Yeah.
All right, so that is our cursive L, our slant height. And so we're ready to just plug in. So we've got pi times, and I'm not going to use my units of measure, 4.5 times my slant height of 13 plus 2 pi and my radius of 4.5 is going to be squared. So find each of these pieces separately. So 13 without the pi, so don't multiply the pi through. 13 times 4.5 is 58.5 pi plus 4.5 squared is 20.5 times 2. So you get 40.5 pi. So there's our separate pieces. We got our cone and then our hemisphere. And then you're going to add those pieces together. You get 58.5, 99. 99 bottles of root beer on the wall. I don't know why 99 always throws that song out there. But anyway, so you have 99 pi, right? And then its surface area. So our units, are they single, squared, or cubed? Squared. And then the approximate surface area, take 99 and multiply it by pi. You get approximately 311.02 meters squared. Okay?
That was good.
Right? Last problem. This time, the Henleys have a silo on their farm to store grain. I had to count the grain in a silo one time when I was an accountant in Holyoke, Colorado. Let me just tell you, those silos are really tall.
Wait, what is a silo?
A silo usually has it holds grains. It stores grains for farms or what? Okay, here's what you do, because you use volume. You use volume. So the grain either peaks up like this. So you can imagine if you're, dropping grain into a cylinder, it either peaks up like this or it peaks down. So my job was to see, and along inside the silo are markers that tell you how many feet or yards or meters, whatever the silo is marked in, how high that is. So you can see how high it is, but then you've got to measure the dip or the peak. So you can account for that extra or whatever. So see, I had to use math. There was no formula given to me for that. I had to derive it and figure it out. So I'd have to climb up a ladder. Now, mind you, this was at a pig farm.
That's even worse.
So at a pig farm, apparently people can give pigs diseases. They're not worried about the pigs giving me a disease, but me giving the pig a disease. So every time you go on a pig farm, you have to take a shower, head to toe shower, hair all the way, whatever. And so the end of the year is December, right? So men work at these pig farms usually. So they don't care about blow drying your hair or anything like that. So you go on, you take your shower. On the other side, you put on clothes that they have there for you. Men's clothes, I might add. Men's underwear, I might add. Dicky suits, that's really, I was looking lovely. Let me just put it that way. Because you can't use your own clothes because you might actually have a disease on your clothes brought into the pig farm. So you leave your other clothes on the other side. So you do your stuff at the pig farm, you come back out, you have to take a second shower before you can leave the pig farm and then get back in your clothes. So you had to take 2 showers every time I went to a pig farm. I visited 6 pig farms in one day. So I took 12 showers, well 13 counting the one I took that morning. And I had no idea what I was getting into. So I'm climbing up this ladder. I only did it once. Climbed up the ladder. I have wet hair because there's no blow dryer. And it's December in Holyoke, Colorado. We're from Arizona. What happens in the winter when you go outside with wet hair? It freezes and your hair breaks off.
Yeah, that happened in Colorado.
Correct. And plus the water in your ears freeze. And that's really a lot of fun. So after I went up there the first time, I made the guy go up there. Every time afterwards, I'm like, okay, how high is it peaked? How low is it dipped? So I just counted on my little sheets. So this is a real thing. So here we go. Assuming the entire space is used, which it isn't, what is the maximum amount of grain that the silo can hold? So what am I doing? Surface area or am I doing volume? Volume. So I'm going to find, well, they just said how much can it hold. They didn't actually say volume.
Well, I mean, because you're telling us to find the volume, how you have to.
Oh, okay. Well, that's true. So we're going to find the volume of a cylinder. So how do we find volume of a cylinder?
Pi r squared h.
Okay, so big B times H. Our big B is pi r squared times H. Plus, I'm going to add to that half of the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed, and we are going to divide all of that by 2, won't we? So I put my 2 in there immediately. We're going to calculate the volume of the sphere separately and throw it up there and divide it by 2. So all I need is radius and height, correct? Now this is height of the cylinder, not height of the whole thing. They've given you height of the whole thing, haven't they?
Yeah.
So what's the height from here to here? Okay, so George is using his brain. Now it's not 22 because the whole distance, the whole distance from here to here is 22. What is this distance from here to here? 11, right? So we're going to take and subtract 11 from here, and don't I get 34 feet? So 34 feet is the height of the cylinder, okay? And the radius of the sphere is 11. And isn't that going to also be the radius of the cylinder? So we have everything we need. Let's just plug and chug. I'm not going to worry so much about an exact answer on this one. So my radius is 11. I'm going to square that times the height of 34 plus 4 pi times my radius of 11 cubed, all divided by 3, and then all of that is going to be divided by 2. Don't let that big ugly fraction bother you. So let's figure out this part first. I can actually figure out that exact answer. So we got 11 squared, which is 121, times 34. So that one's easy. That's 4,114 pi plus. Let's see if this gives us a lovely answer. So we're going to take 11 in cubits. So 11 to the third power is 1,331. We're going to multiply that by 4. So times 4 equals 5,324. Divide by 3, which is a lovely long decimal, 1774.6666. So I took 11 cubed times 4 divided by 3, right? And then I'm going to divide by 2. Divided by 2 gives you 887.33 times pi. So we get an approximation for the second half of 2787 point, and I'm just going to round on here, but not my calculator, 64. So then we're going to finish it up over here. I multiply by pi on that one. It's just easier. So then I'm going to add to that the 4,114 pi. So for some of you with your display calculators, you might want to use a parentheses. So you're going to add to that long decimal, parentheses, 4114 times pi, end parentheses. And you get a volume that is approximately equal to 15,712.15, and our units of measure in feet, so that is feet cubed. So that's how much grain that silo can hold. So we know how much to order when it's empty. Any questions?
Wait, hold on, I'm still working on that.
Okay. You like my pig story?
Pretty interesting.
Holyoke, Colorado at the time, 1989, had one stoplight. I was a young mother in a town with one stoplight, really excited that I was by myself, for once, on a trip with an American Express card. Nobody in Holyoke, Colorado took an American Express card. The closest ATM was 40 miles away. It was terrible. I had a choice of either eating dinner via the Circle K or the little hotel where I was at. They had a microwave in the office. There's no microwave in my room. I think there might have been a refrigerator. So I finally found a bar that had a Mexican restaurant, and that's where I ate all week long.
Where is that city?
It's near Denver.